All right, this is our last lesson of semester 1 in chapter 6, lesson 6-6. This is all about trapezoids and kites. In this video, part 1, we're going to focus on trapezoids, and in the next video, we're going to talk about kites. So a trapezoid is a four-sided shape, a quadrilateral, with exactly one pair of parallel sides. So is a trapezoid a parallelogram? No, it's only got one pair of parallel sides. Parallelograms have to have two pairs of parallel sides. So we're going to write not a parallelogram. It is not, but it is a quadrilateral. It's a four-sided shape, right? And here is a picture of a trapezoid. So we've got the top and the bottom are parallel to each other. This guy right here and this guy right here are parallel. What's not parallel are the two sides. This side SR is not parallel to this side TU. If we kept drawing these lines, they'd eventually intersect somewhere up here, all right? So they're not parallel. So this is a trapezoid. There's a more specific type of trapezoid called a isosceles trapezoid if the two sides that are not parallel, so we have the top and the bottom, the bases, they're parallel. The two sides, or the legs, they are not parallel, and if they are the same length, then this is an isosceles trapezoid. Just like an isosceles triangle, right? When we have two legs, which are the same length, and then the base, right? It's kind of the same thing, except we just cut off this top part of our triangle, right? So we've got this flat line up top, this line parallel to that flat line on the bottom, this is our base, and then these two legs, if they are the same length, then this is an isosceles trapezoid. They might not be the same length, right? Let's draw a couple examples here. I could have a trapezoid that looks like, whoops, my pin's dying there. Trapezoid that looks like this with this guy and this guy. A trapezoid that looks like this way out here, right? Or I could have one that looks kind of symmetrical on either side. So here, the top and the bottom are parallel to each other. Same thing here, top and the bottom are parallel. That's all we have to know that this is a trapezoid, that it's got four sides, and at least one pair of those sides are parallel. And then the sides not parallel, here, they are not equal. Let's say this one has a length of 5 units and this one has a length of 6 units. Let's say this one has a length of 5 units and this has a length of 9 units. And then here, they are going to be the same. Let's say this one has a length of 4 units and this one has a length of 4 units. So this would be an isosceles trapezoid. These would just be trapezoids. Nothing special. This is isosceles. If it's an isosceles trapezoid, these top angles, these top base angles are going to be the same size. And these bottom base angles, this guy and this guy, are going to be the same size. Right? And also, when you add these together, these are going to be supplementary. These aren't going to be supplementary. These are going to be congruent. They're next to each other. But these are going to be supplementary, right? So the interior angles between our parallel lines are supplementary, right? These are interior angles, but they're not in between parallel lines. They are not supplementary. They are congruent in an isosceles trapezoid. Hopefully this is making sense. Okay, and the only other thing you need to know about isosceles trapezoids is that the diagonals are the same length. So this would be the same length as this, right? So the legs are the same length. The base angles are the same size. It's the two angles off of the line that's parallel, here and here. These two angles are the same. And then the diagonals are the same length. Up here, the only thing that's true in a regular trapezoid is that the top and the bottom are parallel. There's no other congruency markings or anything else we can figure out. Okay, so if we do some examples, first one here, they have it drawn for us. They have the vertices given of a quadrilateral. We have to figure out if it's a trapezoid, right? So we can graph it. We can tell that it's not a parallelogram, obviously, but it looks like it's a trapezoid, so how could we figure it out? You can find the slope of all four sides, and if two of those four sides have the same slope, then you know one pair of opposite sides is parallel, right? So here, the slope of this side is 2. The slope of this side is 0. The slope of this side is -2. And the slope of this side is 0. So since the top and the bottom have the same slope, they are parallel. So this is a trapezoid. because of this top piece right here. One set of opposite sides are parallel, so it's a trapezoid. And then they compared the two legs, right? We have leg AB. It's not parallel, it's the leg. And then this guy CD. They compared them, they found the length of both of those. And look, they're the same length. They have the exact same length. So when the two legs, the two non-parallel sides, are the same length, this is a trapezoid. Isosceles trapezoid, right? I'll highlight that part. Too many things I'm reaching for right now. So when one pair of opposite sides are parallel, it's a trapezoid. When the other opposite sides not parallel are the same length, when they're congruent, it's an isosceles trapezoid. Okay, so let's do some exercises together here. Hopefully this is making sense. Find each measure, the measure of angle D. So in a parallelogram, opposite angles are congruent, but that's not true in a trapezoid. What we see here, though, is that these two legs, the two non-parallel sides, are marked congruent. So this is an isosceles trapezoid. So we're going to apply the rules of isosceles trapezoids, right? We know that this top angle is going to be congruent to this top angle, and that these bottom angles are congruent. And we also know that these two consecutive angles in between the parallel lines, these two on the side, are supplementary. They add up to 180 degrees, right? So if this is 125, I know this is 125. If this is 125 and the two of these add up to 180, this would have to be, 55. And this would have to be 55. Right? And if we added up all four angles, they should add up to 360 degrees because any quadrilateral, the sum of the interior angles is 360, right? If we use the whole 80 times n minus 2, because it's a polygon, so that works, right? 4 minus 2 is 2. 180 times 2 is 360. Okay, so if we added these together, 125 and 125 is 250. 55 and 55 is 110, 250 and 110 is 360, so that works. So the measure of angle D is 55 degrees. Okay, number 2, the measure of angle L. These are not marked congruent, but we see that this length is 5 and this length is 5. So this is also an isosceles trapezoid. These two legs are congruent. Okay, so if this is 40 degrees, we know this has to be 40 degrees. And then these two angles have to be supplementary, and these two have to be supplementary. So this one down here, angle L, must be 140, and angle M has to be the same size, 140. And if we added up all four, they'd have to add up to 360. So 140 and 40 is 180, 40 and 140 is 180, 180 and 180 is 360, that works. So the measure of angle L is 140 degrees. So the two angles coming off of the base, which is either the top or the bottom, they're both bases, this guy and this guy, those two angles are the same size, these two angles are the same size, and then when you compare the angles next to each other, they're supplementary, if that makes sense. Excuse me. All right, number 3. Coordinate geometry. Find each quadrilateral with the given vertices, verify that it's a trapezoid, and then determine if it's an isosceles trapezoid. So just like we did at the top, we're not going to graph it. They don't give us graph paper here, but we are going to find the slope of each line, right? So obviously, if A, B, C, and D are the corners, we're just going to go kind of in order. So AB is going to be the first line. And we use the slope formula, y minus y over x minus x. 1 minus 2 over negative 1 minus 3, negative 1 over negative 4, which is positive 1/4. The next line would be BC. The slope of BC is 2 minus negative 2 over 3 minus 1. 2 plus 2 is 4. 3 minus 1 is 2, so that's just 2. The next line would be CD. Y minus y, negative 2 minus negative 1 over 1 minus negative 2. I'm squishing in here. Negative 2 plus 1 is negative 1. 1 plus 2 is 3, so that's negative 1/3. And then the last side we did AB, BC, CD, and then DA. Circle back around to complete it. And DA, the slope is, let's see, negative 1 minus 1 over negative 2 minus negative 1. Negative 2 over negative 2 plus 1 is negative 1. It's just positive 2. Okay, so 2 of my sides have a slope of positive 2. So that means this is a trapezoid. One pair of sides has the same slope. So yes, it's a trapezoid. Now, is it an isosceles trapezoid? How do we know? Well, if these two sides are parallel, then the two sides that are not parallel have to be the same length if this is isosceles. This is their slope. They're not going to have the same slope, but they should be the same length. So we're going to find the length of AB and the length of CD using the distance formula. So AB equals square root of x minus x squared, negative 1 minus 3, squared plus y minus y, 1 minus 2 squared. Then we just start simplifying. That's negative 4 squared is 16. Negative 1 squared is 1. That's square root of 17. And we don't really care what this number is, but if the other line, CD, is the same, then we know this is isosceles. If it's not the same length, then it's not an isosceles trapezoid, it's just a regular trapezoid. All right, so square root of x minus x, 1 minus negative 2 squared plus y minus y, negative 2 minus negative 1. 1 plus 2 is 3. 3 squared is 9. Negative 2 plus 1 is negative 1. Negative 1 squared is 1, and that's square root of 10. So they are not the same length. So this is not an isosceles trapezoid. It's just a regular trapezoid. Right? We would do that. I ran out of room here, but we would do the same thing here. We would find the slope of all the sides, side JK, KL, LM, and MJ. If two of them are the same, we know it's a trapezoid. If the other two that have different slopes are the same length, then it's an isosceles trapezoid. Okay, and then the last little piece here for trapezoid, H, J, K, L, M, and N are the midpoints of the legs. Okay, so for this, we didn't really touch on it up top, but it did mention it. Let me zoom in a little bit. Whenever we have a midpoint of this leg and a midpoint of this leg, and we draw a line to connect to them, this line is our median, right? The two endpoints of the median are the midpoint of this side and the midpoint of this side, and the median is always parallel to the top and to the bottom. So it's exactly in the middle, halfway up, halfway down, and it's parallel to the top and bottom, okay? The thing about the median is that if you add the length of the top plus the length of the bottom and divide by 2, you get the length of the midpoint. It's exactly halfway between this. So if this was 4 and this was 6, 4 plus 6 is 10, divided by 2 is 5. The length of the midpoint would be 5. If the length of the top was 3 and the length of the bottom was, I don't know, 7, 3 plus 7, 10, divided by 2, 5. 3, 5, 7, right? It's exactly halfway. The length is just average the top and the bottom, and that gives you the length of the midpoint. So the median. So this line is called the median. The two endpoints are midpoints of your legs on the side, and the length of the median is you add the top plus the bottom, divide by 2. That gives you the length of the median. Okay, so questions. If HJ is 32 and LK is 60, find MN. If the top is 32 and the bottom is 60, find the middle. So we're going to add 32 plus 60, divide by 2. The length of the top plus the length of the bottom, divided by 2, equals the length of the middle. 32 plus 60 is 92. 92 divided by 2 is 46. So the length of the median is 46. That's halfway between 32 and 60. Okay? And then if HJ, the top is 18, and the middle is 28, find LK. Well, remember when you add the top and the bottom and divide by 2, you get the middle, right? Well, here we know the top. We don't know the bottom, but we know when we add them together and divide by 2, the middle is going to be 18. No, sorry, the middle is 28. So 18 plus what divided by 2 equals 28. Same thing I did here, but instead of looking for this number now, I have that number. Now I'm looking for one of these, right? So let's pretend this is x, and we're just going to solve for x. Okay, so to figure out what x is, first thing I got to do is get rid of this divided by 2, so I'm going to multiply by 2. And whatever I do on one side, I got to do to the other. So these 2's cancel. 18 plus x equals 28 times 2 is 56. Minus 18 from both sides. And x equals 38. So the length of the bottom would have to be 38. So the halfway, if we added 18 and 38 and divide by 2, we should get 28, right? This is 18, this is 38, this is 28. Makes sense? This is 10 more than this, and this is 10 less than this. So it should be the equal difference between the top and the bottom. Hopefully that's making sense. Let me know if you have questions.